Hello out there. This is a viewer question about finding the points on the graph of a specific function in which the tangent line is horizontal. So let's just quickly remind ourselves when this is going to happen. So if I have some graph, then I'm looking for places where the tangent line is horizontal. Okay, so this should be flat. And so there'd be another instance. Okay, and the places where this is going to happen is where the slope of the tangent line is 0. But the slope of the tangent line is precisely the derivative. All right, so we're looking for where f prime of x equals 0 for x in this interval 0 to 2 pi. Okay, so that's what's, these are the important pieces we've been given. Okay, fine. So we need to compute the derivative. Not too bad. Let's see. So the derivative, let's see, derivative of 2 of cosine of x is going to be negative 2 sine of x. And then the derivative of cosine squared, well, we have to use the chain rule on this. So this is going to be, well, there's going to be eventually a minus. I'm just going to leave a space here. So it'll be 2 times the cosine of x, right? We bring the 2 down. But then we have to multiply by the derivative of cosine, which is negative sine. So I get a minus and then a sine of x here. Okay, now we want to know where this is equal to 0. So negative 2 sine of x minus 2 cosine of x sine of x equals 0. Well, this happens if and only if, let's see, both of these have a negative 2. Let me just divide by negative 2. That should make my life a little bit better. So I'll have sine of x, right? I'm dividing by 2. Sine of x plus cosine of x times sine of x equals 0. All right, now you might be tempted to move stuff over to one side and then divide by the sine, but that actually will cause you some problems if you're at a place where the sine of x is equal to 0. So instead of doing that, we're going to factor. Okay, so this is equivalent, and we're just going to factor the sine of x out. So I have sine of x times the quantity 1 plus cosine of x is equal to 0. Now you notice here I have a product. Something times something equals 0, right? So if I have a times b equals 0, this can only happen if a is equal to 0 or b is equal to 0. So in this case, I either have sine of x is equal to 0, or 1 plus cosine of x is equal to 0. All right, and of course this last bit, that's equivalent to saying that the cosine of x is equal to negative 1. All right, well, let's look at these cases, and I'm going to head to my unit circle. This helps me out here. So remember, if you have any point on the unit circle, or say that angle is x, then the coordinate is cosine of x, sine of x. So if I'm looking for where the sine is 0, that means I need that the y coordinate would be 0. And the y coordinate is 0 over here at 0. There'll be another one over here at pi. Oops, we got that in green. Okay. And then if we keep on going, we're going to get another one back at the original 0, but now we can think of it as 2 pi. Okay, and that's important because the domain included both 0 and 2 pi. So this tells us that the sine will be 0 when x is equal to 0, pi, or 2 pi. Okay, now where will the cosine be negative 1? Well, the cosine is the x-coordinate. And remember, this is a unit circle. So the x-coordinate on the left is negative 1, but that's already a point we have. So this would tell us that x was equal to pi. That doesn't give us anything new. So we conclude from this that the horizontal tangents occur at x equals 0, pi, and 2 pi. And we can verify this by looking at a graph. So let's put a graph in here. So we can see we get horizontal tangents there, and that's at 0. We get another one down here, and that's pi. And finally, our last one is here at 2 pi. So 0, pi, and 2 pi as we expected. All right, I hope this helps.